Hi, and welcome to episode 25 of the ChessTDD series. In this episode, I started off trying to correct a mistake I had left with last time, which was that the pawns for the opponent's side of the board are not flagged as being second player's pawns. So that's a pretty good opportunity to write a unit test to drive out that deficiency. I've noticed a bug. I'm going to write a test to make sure it doesn't happen again. So there was also another goal on the Trello board, which I'll get to in the narration or in the housekeeping sense in a little bit here. Sorry, I'm still kind of gathering my thoughts while you watch me struggle to name that class. In the housekeeping sense on the Trello board, I'll go move that over later too, but I was kind of killing two birds with one stone on this one. So what I'm going to do is I'm going to create a test scenario where piece positioner, given a normal-sized board, should. And what I'm looking at doing here is saying, all right, the given for this piece positioner class is we're going to create an 8x8 board. And if we have an 8x8 board created, there are certain things that piece positioner should do when these methods are invoked in terms of setting up the board. So the first thing I'm going to do here is write a test that says, in essence, pick a pawn, any pawn from that row, and it should be a second player piece. And you're going to have to watch me struggle a little bit here because with the gap between these recording sessions, I tend to forget what the object graph looks like. So I kind of blunder my way through it a little bit. Apologies for that, but I think it kind of comes along with no filtering or polishing what goes on here and just showing you the way the sausage is made, so to speak. So I'm going to create a board, and I remember this much at least, that the piece positioner takes a board as its input, so I'll pass that board into the piece positioner. And then what we need to do is call the setup standard board method. Got that wrong at first, but I want to say let's set up a standard board and then let's grab a piece from the 7th row and essentially let's assert that that's a black piece or player 2 piece. So I'm going to say let's assert true, and I think I wind up changing this to false. I'm going to actually get that piece, so I need to go back to the board rather than the positioner. And I'm going to say, let's get a piece. And I do remember this board coordinate 4 method. Let's say 1, 7, which is the, wow. I was having a bit of trouble with the numbers there. Anyway, sorry. So let's just pick the first pawn on the left and let's assert that that is a player 2 pawn. Took me a minute to get the IntelliSense going here. I think I might have outsmarted myself a bit. Here I was looking to say, oh, well, if I go querying piece, isn't there something like, you know, player 1 or player 2 or whatever I called it? And yep, there it is first player piece. Why the IntelliSense wouldn't cooperate with me here, I don't know exactly. But I tried it again and then it worked. And then I believe the test passed because I'm calling the wrong Boolean logic. So I want to say that this is false. Now I've got a failing test. Finally, however many minutes in, I've exposed the bug I set out to expose. So now this is going to be a fairly easy one to correct, right? Well, kind of. I'm calling into this auxiliary method that doesn't have the is first player piece parameter. So what I'm going to do is I'm going to add that in. In a spoiler, I'm also going to add it in wrong and make a dumb mistake. And frankly, see, if you look at the method below, I didn't realize it as I was doing this. This should have been is first player piece equals true. I'm going to pass it into pawn, and then I'm going to be flummoxed for a little bit by why a handful of other tests start to fail. And then I'm also going to struggle with ncrunch for some reason. I guess it's just not my night with the IDE. And I was using Eclipse earlier today for some Java stuff, and it wasn't my day with that either. So I think just not my day for IDEs in general. But anyway, at this point, I'm I'm trying to get ncrunch to show me the failing tests, and I don't remember exactly what the struggle was here. Eventually it did. But what I love so much about using this tool is this visualizing of pass through the code and this easy access. There we go. So at a glance, I can see, oh, there's 3 tests that are failing covering this. And I was looking at this thinking I wasn't doing anything with the white moves or anything like that. So what gives here? And after a little bit, I went back to this other method and started to think that maybe I was doing something a little goofy that was affecting the white pieces instead. That's when I caught on, oh, yes, I am calling everything is first player piece, or I'm calling nothing is first player piece. All the pawns that on the board being set up here are going to be black pawns. That's not what I want. So oops, fix that. Now it's green. The beauty of this, and thinking back to the days before I used test-driven development, is I would have put that in and it never would have registered that that was something that I was doing that was wrong. And it probably would have been minutes, tens of minutes or something before I ran an application. And it would have taken me a long time to track down that bug. Now, you know, almost immediately I see this red that I'm not expecting, and before I can get very far, it lets me know that there is a problem and that I'm kind of off the rails. So what I'm going to do here is I'm saying, like, all right, I've got this method. Before all this logic was kind of ad hoc in unit test classes, but now this is a first class production implementation here. And what that means is, since I have these public methods, I should be doing some guarding against nonsense parameters that maybe I didn't need to worry about anywhere before. So sure, there are probably exceptions that get thrown by the board or the pieces or something if you give them out of bounds parameters, but we shouldn't let it get down into the call stack. So if I am writing a class and I'm giving my consumers a public interface to the class, I shouldn't rely on things that I'm using internally to bubble up exceptions that I pass on to them. I should be explicit about this, in my opinion, that is. So if you pass me a parameter named foo, and it's a bad argument, I should throw an argument exception about foo. I shouldn't let something I call throw a null reference exception or some other argument exception or whatever. I should be very clear about that and deliberate, because the implementation under you could always theoretically change, and now suddenly your interaction with your consumers is different without you even changing anything. So I'm doing a little bit of refactoring here and going towards the style of setting up unit tests that you're used to seeing. And I pulled out this first pawn on the left for readability, so that I can just say I want to assert that the first pawn on the left up there is not a first player piece. With that extracted, this gets to be a pretty easy call. I'm going to assert that passing in a bad row here should throw an exception. But first I'm going to quickly eyeball it and say, okay, yeah, we're getting an exception. I wasn't sure whether that would happen or not. And in fact, I see that I'm getting an argument exception. Now, that's sort of good news, bad news. That's the outcome that I want. So this test is going to go green. But this is exactly the scenario I was just describing. I don't really want to rely on some class that's internal or some collaborator of the piece positioner class to throw that exception. Piece positioner is the one saying, hey, you're passing me a row I can't use. Piece positioner should be throwing an exception deliberately. What I want here in setup standard pawns, where this exception is getting thrown, I want to throw an exception with that argument name. So what I was doing here is kind of going through and looking at the red, because I've only got one failing test, so in ncrunch, the red traces the path that this is taking. So I'm trying to figure out, okay, what is it that's throwing this argument exception? I was looking around in board, or board coordinate, whatever that was, and it didn't seem to be in there, so maybe it's in the piece, maybe it's in the add piece method of the board. I think that's where I went next. There you can see the red X on the left. Throw argument exception. I kind of moused over it while moving the cursor around. I guess I could have seen what the exception was originally in the unit test class and done a text search for that, but I found it nevertheless. So what I have here is right, in that there's an exception being thrown, and it's even the right kind of exception. It's just not the exception that I want. So what I was kind of puzzling at here for a minute was, you know what I could do? I should somehow assert not only that this is an argument exception, but that it has the message row. And that's when I got to thinking. One of the things I could do, or I could have, instead of using this extended assert shortcut, I could have invoked the method, caught the exception in the test method, and then asserted that the exception's message was what I wanted it to be. I have a rather visceral dislike of having try-catch logic in test methods. I'll take a stab at why that is. It might just be irrational bias, but for me, that exception handling logic is sort of like a rip in the space-time of your code. It wrenches you out of the regular operation of the call stack and sends you like careening across the code base. So I like to encapsulate that as clearly and sort of out of the way of most stuff as I possibly can. It heavily detracts from not only readability, but how easy or hard it is to reason about your code. Exceptions and exception handling are really hard to reason about. Maybe I'm just dumb, but it's such a fundamentally different operating paradigm where it's almost like a go-to that can just hurl you anywhere. No, I'm not trying to get overly worked up about this or anything, but that is just the reasoning behind why I really gravitate away from catching exceptions in unit tests. It's just not clear what's going on. So what I started doing here that actually gets, and I mentioned it in the type out of the post too, this gets really weird. Writing unit test helping utility like assert, you start to kind of use your production code as test. It's like an inversion of what you expect. There are a couple of ways you could do that. I guess in theory, I could actually write unit tests for this. And because I have extended assert up on NuGet, I probably should at some point, since it's sort of a utility in its own right. But for the purposes of this code base, I just reason that there are any number of unit tests that are hitting this initial throws method, so I can do some refactoring in here while everything's green, and feel pretty good that if it stays green, I'm not breaking anything. I am cheating a little bit because you can see in there that there are, in fact, 2 lines, although it's only one path through the code, that are not green, which means that nowhere in the code am I failing a unit test because I'm expecting an exception and not getting one. Now, that really is enough to make your head hurt there, because why would I ever leave a failing unit test in place? That's something the production code couldn't exercise. Anyway, this is a fairly low-risk refactoring, so I'm kind of going with it. I will admit that this is not as diligent as I could be. There's only, for the sake of doing these videos, probably a certain amount of yak shaving that I want to tolerate. I don't want this to somehow pivot into me making a video about my extended assert library. So I'm going to ask you to extend me just a bit of latitude on this and assume that a basic extract method refactoring is going to go all right here. At least it will once I figure out all the rules behind C# generics, which I almost never use anymore because I rarely use C#. I forget why exactly I have to specify the type there, but such is life. So now I've extracted out this assert exception match because I want to do the same thing here in this new overload I've created. I want to be able to assert the executable, and then I want a stronger assert condition where I can say, not only should this type of exception be thrown by this executable, but it should also have this message. So in this new method, I'm going to have 2 asserts. And then for the fail case, I'm going to extract a method again This is, I think I can just actually rely on the refactoring tool to do it for me because I don't know, that assert I had before was a little busy. CodeRush might not have quite liked that exactly. That's interesting. Oh, I am putting a message in here, that's right. In essence, saying something like the exception message was not what we were expecting. I'm not really sure why I had to stand there and think about that for a minute. Guess maybe it's been a long week. But then, you know, with the spoiler that I had, I will go and extract the fail assertion. I started to type it out and then realized, hey, this will probably work as an actual extract method, which I do. I feel a little less out on a tightrope when I rely on a tool to do an automated refactoring because there you kind of get the weight of the broad tool using public. If extract method refactorings were failing, there would be a lot of people out there complaining about it, and there would be updates and such. It's, again, not bulletproof. I wouldn't stake my life on it or anything, but it's gives you a little more reassurance as you're going along. So after that pretty large bit of yak shaving, I now have a way to get to a failing test. And now I'm failing because, yes, I'm getting the kind of exception that I want, but it doesn't have the message that I want. And the convention I've generally used with these argument exceptions is to toss them along with the name of the parameter. I think maybe in the latest version of C#, there's a way to do that without a bunch of clunky reflection semantics, but I don't honestly recall. If not, there should be, or maybe it's in C#6. I'm not positive. Okay, so what I was floundering here with was the best way. So, okay, I'm getting this bad parameter row. Now I have to check it against something. I was kind of scratching my head and looking at these different collaborators and saying, really, is there no way that I can pass the row number into something here? You know, whether that's the board or the piece or whatever. Got to be something that will let me do a sanity check here. And again, this is the product of not really remembering my object graph. So I look around and see, like, okay, I can do validation if I have a coordinate, but that puts me in this sort of strange position where I'm only being given a row. So I could kind of manufacture a coordinate out of that row, you know, assign an arbitrary column and then use the board coordinate validation. That struck me as kind of icky. So I didn't do that. The next thing that I thought I would do is say, well, okay, if the method doesn't exist, hey, go write the stub of the method you want to exist. I'm a big advocate of that. So I think I said something like, you know, board dot, is this row valid or something? But then as I was doing that, which you'll see in a second here, a slightly less, I guess, redundant or cumbersome solution occurred to me. So here you can see I'm saying basically trying to get to the bang operator. If the target board does not have, if this row is not valid for the target board, then I'm going to throw an exception. And I'm going to be sure to give it the right name. Now this test will pass when I implement this method properly. So I looked around for a minute and I felt a little uncomfortable with this because there's just not great cohesion. Things like add piece, remove piece, etc. It's all this, you know, stuff about adding pieces to the board and moving them around the board and such. Now I'm going to have this thing that takes a row and returns a Boolean, and it just didn't feel right, but started to put it in here anyway. And then I kind of got a better idea, I think, once I scrolled up here to the top. I see that there's this pieces and there's this board size, so I put this in and I start thinking about how to implement it, and I guess I'm going to say, well, if the pieces array, oh wait, there's this board size thing. Then the light bulb came on and I said, well, why don't I just make the board size something that the consumer can see from here? I don't need to write a whole other method where I pass in a row from the caller here, from the piece positioner, I can just say, is this row bigger than the board size? So that's what I did. I changed up the ideal world as I see it. Forgot to delete the not operator there. So ideally, I would have something called size that I could compare to row, and I could say, wow, I really struggled with that too. If the size of the board is less than the row being passed in, that's a problem. I need to throw an exception. And then once I define the ideal world, I go and make it happen in the collaborator. Oh boy, I think I forgot to delete that that field that it created in there. I'll have to go put that on the to-do list for next time. So I'm going to return the board size. I think I finally figured out my mistake after seeing that made it a Boolean. The mistake in the other class of forgetting the not operator, that is. So I get rid of that, and now what I have is a implementation that sends me green, and that's pretty good news. Now, there are other things to do, like what if I pass in a negative board size, or what if I pass in a bad board size to this other method? We'll get to that stuff maybe in another episode. Here I'm doing a thing where I'm just going to sanity check. So, okay, I'm looking for some boundary conditions. I could write all those cases out explicitly, but I just want to check my understanding. So 10, 9, I'm good. 8, 8 is actually valid, so it turns red, which is exactly what I wanted. So I'm low on time here. I will wrap up for this episode. I forgot to do the actual housekeeping for GitHub in the episode, but I did check the code in out of band. I'm also, just so you know, probably going to add a couple of cards here to remind myself of some stuff I forgot in the episode as I was trying to wrap up in time. So look for those next time, and I will see you next time.